Hi everyone and welcome. In this video we will see unidirectional Modbus serial RTU RS485 to MQTT converter or publisher using JavaScript for single Modbus serial device. So your JavaScript will act as a Modbus serial master which will connect to your Modbus serial device, okay, and then it will publish your Modbus serial device data to MQTT broker. And MQTT broker can be any type. It can be your local MQTT broker or it can be your cloud MQTT broker. So you can monitor your Modbus serial device data through MQTT client software, and you can also create a dashboard in any of your MQTT client software. Okay, and if you want to get the code, then you can click here after this video to get the code. Now once you download the code, you will have few files inside the code, and the main file is the index.js file. Okay, and index.js file will work based on the config.json file. So in the config.json file you will mention that our serial device is connected on which COM port, okay, and which register we are going to read. So everything we have to mention here along with the MQTT broker details, and according to that our index.js file will work, which is our JavaScript file. Okay, now let me show you the data flow diagram. So here we have the JavaScript which will act as a Modbus serial master to connect with any Modbus serial device, and after connecting with Modbus serial device it will read the data which we have configured in the config.json, and then after it will publish the data to MQTT broker, and with the help of any MQTT client software we can read the data. Okay, it can be HiveMQ, Cloud MQTT broker, or it can be your local host Mosquito MQTT broker. Anything is fine. So let's start the Modbus serial device, or you can say virtual Modbus serial device in our system, and let's install the library and let's run the JavaScript code. So to create the Modbus serial device, I'm going to use MoreSim software. And here we are going to connect with the COM1 port with 9600 baud rate, data bit 8, parity none, and the stop bit 1. So you can see our device is up and running. Okay, Modbus serial device. Now I'm going to add one more file here, okay, and it will be my input register. Okay, Modbus point type is input register, as you can see here, input register, and this one is for holding register. Now I'm going to change the length to 10. Okay, that's fine. Okay, so our Modbus serial device is up and running on the COM1 port with 9600 baud rate, data bits 8, parity none, and the stop bit 1. Now the same Modbus serial device is connected with the COM2 because COM1 and COM2 is internally connected. So we are going to use COM2 when we are going to read the data from this device. Okay, so now let's configure our config.json file. So here is our config.json file. So first of all, you have to specify that your Modbus serial device is connected on the which COM port. So you can see it's connected on the COM1, but COM1 and COM2 is internally connected. So I'm going to use COM2 here. Baud rate is 9600. Okay. Parity is none. Stop bit is 1 and the data bits are 8. Now the slave ID. So here you can see the slave ID is 1. And the interval, so interval is in the millisecond. So right now it's a 5000 millisecond, so it's a 5 second, but I'm going to change it to 2000 milliseconds, so it will be 2 seconds. So every 2 seconds it will read the data and it will publish to MQTT broker. Now here you can see register and what register we are going to read and going to publish to MQTT broker. So first register type is the holding register which we are going to read and publish to the MQTT broker. Now the starting address is 0. Okay, so it will be 40,001 and the ending address is 2. So from 40,001, 40,002 and 40,003. So this 3 register will be read and it will be published to the MQTT broker. Now let me auto simulate this one. Now the second set of register we are going to read is the again holding register, the address starting with the 5 and ending at 7. So 5, 6, 7, total 3 holding register, and it will be correspond to 40,006, 40,007, 40,008. So I'm going to simulate 40,007, the middle one. Okay. And the third set of register we are going to read is the input register, and the starting address is 0 and the ending address is 2. So 30,001, 30,002 and 30,003 will be included in this one. So I'm going to simulate 30,001 input register. okay, and 30,003. Okay, so that's it. Now this will be the tag name which we are going to publish to the MQTT broker. If you want to change the tag name as per your device, then you can change it like voltage, frequency, power, anything. Okay, humidity, temperature, anything. But right now it's a holding register, directly holding register data. So that's why I have used holding register tag 0, holding register tag 1. But as per the actual device, you can change the tag name. Okay, and whatever you change, it will be populated to the MQTT payload. Okay, so I hope this thing is clear. Also, you can add coil and discrete input here as a register set to read and publish it to MQTT broker. Now here you have to specify the MQTT broker details like broker IP address or host name, broker port number, username and password if it is required to connect with MQTT broker. And here is the base topic inside which we are going to publish our entire register data, okay, or you can say our Modbus device data. So that's it about the config.json file. So we have configured our config.json file properly to read the data, and also we have provided the broker details to publish the data to MQTT broker. Now we will save this one. We will open the command prompt at the same location to install the necessary library, and to install the library you have to run the command npm install. Okay, you can see added 64 packages. So everything is installed successfully. Now we can run our index.js file to read the data from Modbus serial device and to publish the data to MQTT broker. So I'm going to run node index.js. Okay. You can see connected to Modbus device on the COM2 and connected to MQTT broker with HiveMQ and on port number 1883. Now we can use any MQTT client software to read this data. Now I'm going to minimize this one. I'm going to open MQTT Explorer as a MQTT client software. Okay. Now we will connect to the HiveMQ broker, and you already know that our base topic is Modbus/data. Okay, so we have to add this topic in the subscription. So you can see it's already added. Okay, and we will connect to this broker, and here you can see, let me close this. Here you can see Modbus. Inside that we have a data topic, and inside that we have a call status, holding register, input register, and discrete inputs. Now in the holding register, you can see holding register tag 0, tag 1, tag 2 is available. Holding register 5, 6 and 7 is available. Now 6th we have simulated, so that's why you can see auto increment or auto simulated values on the holding register 6, but 5 and 7 is 0. If I change the value from here, like if I change the value to 99, then it will be updated here. Okay, if I change the value to 106, then it will be updated here. Now if I change the value for this one 40,008, or you can say holding register 7, then I can update from here like 7. Okay, and it will be available here. Okay, and here also you can see the timestamp. So every 2 seconds it will publish the data to MQTT broker. Now you can also update the input register, and you can also read the input register via MQTT client software. So you can see first and third we have simulated. The second one we didn't simulate it, so second one has a 0 value, and first and third is changing at every 2 seconds. If I change the middle one to 22, then you will see the update in the MQTT Explorer software. Okay, so this is how you can use JavaScript to read the data from your Modbus serial device and to publish your data to MQTT broker. You can use this code in the Raspberry Pi or any other Raspberry Pi kind of devices, and you can continuously read data from your Modbus serial device, and you can continuously publish your data to MQTT broker. You can extend this code to read the data from multiple Modbus serial devices as well. Also, we have already covered a video about Modbus TCP device as well. Okay, so you can read the data from both Modbus serial and Modbus TCP device, and you can continuously publish your data to MQTT broker. So I hope this thing is clear, that how JavaScript is useful to create your own protocol converter, or you can say unidirectional protocol converter for monitoring purpose. Okay, and if you still have any questions or any doubt, then you can always ping me on Telegram, Instagram, WhatsApp, anywhere. Otherwise, we will meet you in the next video. Okay, till then, take care, goodbye, and thank you.